Let's graph this tangent function. Let's pick out those values. A will be 2, B will be 3, pi over 12, that's h. Now that we know those, let's apply our transformations. But first, let's calculate the period. For tangent, the period is pi over b, in this case pi over 3, so one complete wave of tangent, one period should be done in an x distance of pi over 3. Normally it's just pi. When we graph this, typically we count about 4 spaces to the left and to the right of the origin. Let's label the period here, pi over 3 on either side. And normally tangent has vertical asymptotes at plus or minus pi over 2. However, the b value, which changed the period, that split it in thirds. That means we won't have vertical asymptotes at pi over 3, but we'll have vertical asymptotes at pi over 6. Think about dividing by 3. So you might be tempted to label those asymptotes, but not so fast. The horizontal shift of pi over 12 shifts the asymptotes as well as the graph. So our asymptotes would be at pi over 6, but they move right by pi over 12. So if pi over 6 is right here, pi over 12 more will put us right here for our asymptote, as well as on the other side. Here would be minus pi over 6, so the other asymptote should go right here. Now that we've labeled some asymptotes, the origin is normally an x-intercept for tangent, but that gets shifted as well by pi over 12. So we'll have an x-intercept right here, right in between those asymptotes, and then we can graph it like normal tangent finally. The 2 out front, that a value, that's just going to stretch our tangent, but it doesn't do much in changing the look of our graph. It'll still go up and to the right, through the origin, down and to the left, and then this pattern will keep repeating. I won't label it every single time, but we have the exact same pattern going on forever to the left and to the right, repeating every pi over 3. Notice the x distance is pi over 3 each time. If you want an even more detailed solution, make sure to check out the answers.